This thing right here is awesome, and I bet that you'll want one as well. This is yet the best multimeter that I've made so far, and let me tell you why. Well, first of all, it is homemade, and for me that's awesome, especially knowing that I've designed it. But second of all, it is very small, and it also has a lot of modes. It can measure voltage very precisely. And the same for resistance and also capacitance. And if that is not enough, it could also measure inductance, which is usually the tricky part to make. But this one does it very well. And on top of that, it can also have other modes for current measurement, frequency, continuity, a pulse generator, diodes, and who knows other modes that I could program in the code when I update the firmware. And on top of that, it also has a space for a Bluetooth module, so we could connect to our smart glasses from another project and see the measurement in front of our eyes. And that's pretty cool, right? It is very easy to use with both hands, and you don't have to place it over your table as you do with common multimeters, and that's very practical. It is also rechargeable with a USB connector, and it has a battery protection IC and much more. I'm sharing all my files with you and also the code as an open source in case that you want to make the same project. So let me show you all the details about this PCB, the code, how it works, and how to make the entire multimeter. This was more than 1 year of work. So guys, let's get started. What's up my friends, welcome back. Okay guys, so remember that I have multiple videos about such multimeters based on the Arduino. So make sure that you check the other videos because there will be some parts that I won't explain, because I've already done it. The last version of the multimeter worked pretty well with high precision. But it was a bit ugly, too big, and you had to place it over the table, and that's not too handy. I want to have full use of both hands and be able to see the measurement all the time. So that's why I've made this new version that is very small, and you can use it with both hands while still seeing the measurement in front of you. Before we go over the code and all the modes, let's assemble it. With help from PCBWay, I was able to improve my prototype, getting better and better, and this is the final PCB. As you can see, it is very small for a multimeter, measuring only 1.5 cm wide. So guys, get the Gerber files for the PCB from my website, and then we go to our dear PCBWay. Click the Code Now button and insert the size of the PCB. I also select the amount of PCBs and the color of the solder mask, red in my case. You save to cart, and on the next page, you upload the Gerber files that you have downloaded from my website in a zip format. Make the payment, and in under 5 minutes, the order process is done. The PCBs arrived to Spain in around 10 days, and they look awesome, just as I wanted them to be. PCBWay always does a pretty neat job, and I sometimes still can't believe that nowadays you can have prototyping PCBs for only $5, and that will help us creators to develop a new product. Okay, so now we have the PCB, and it's time to assemble all the components. I've used a lot of 0402 components, which are quite small, and might be a little bit difficult to solder, but with patience, everything can be done. And you have the full part list and the values below the video, so check it out and buy each separate component. The most crucial part is the microcontroller, because once it works, we can solder the rest. To make this faster, I've took mine out from an Arduino Nano clone, together with a 60 MHz resonator. And that will speed up the process, and also show you that the chip has the bootloader. Because when you buy a new chip like these ones, they sometimes come brand new, without a bootloader. So use the hot air gun and take out the chip and the resonator. Take the PCB and we must solder the Atmega 328 microcontroller, the resonator, the R30 resistor, the R31 resistor, and the C17 capacitor. We must have these components in order to test the microcontroller. So place some solder paste and solder the IC. You might need to retouch some of the small pins. And then we add the resistors and the capacitors. Then on the back, Solder the wires for the UART port for DTR, RX, TX together with ground and VCC. Now you have to connect an external FTDI module like this one. And to test the microcontroller, I always upload a code like this one here, because in this way I make a communication with the monitor and print a counter. So upload it and open the monitor. If you get the counter from the board, that means that the microcontroller works okay. So now we can solder the rest. So let's solder the battery charging and protection components, which are these ones here. And we also add the USB connector. Now you get a 3.7 volts battery and connect it to the battery pads, plus and minus. Check the voltage with a multimeter and make sure that everything is okay. Also connect the USB connector and check if the charging process works. If yes, we can continue. On the front part of the PCB, we solder all the small resistors, the capacitors, and the on and off switch. Also the ADC chip of 16 bits and the op amp. We also have some small LEDs. Soldering 0402 components is not that difficult, so carefully solder all the components. Then I also add a small push button. Finally, we have to add two slide switches. I've ordered this type of slide switch, but it arrived at my old place. So I had to order it once again, but I don't have it right now. So for this test, I will use these ones, but I have to adapt them. They still have 3 positions and 2 outputs. I take them out from the metal case and shorten the pins. I will connect them like this, so we can slide them at the same time. And the reason that I've used 2 switches is because I wasn't able to find a sliding switch with 3 outputs and 3 lines. We must have that in order to separate the current mode from the voltage mode. In the previous version I was using a rotary switch to do that. But that component is very big for such a small multimeter, so that's why I had to make this approach. Later, together with a supposable 3D printed case, we merge these sliding switches together and they will move at the same time. Okay, so solder the rest of the components on the back as well. And finally we can also solder the Bluetooth module. But make sure that you also solder the 3.3 volts regulator for the module, because more than that might burn it. Check this schematic for all the values and components. You can download it from below. So the PCB is ready. All that is left to do is to add the OLED display. For that you can get this kind of screen and just desolder the display from the small PCB. And then you solder that display on our PCB, and it's ready to go, because it already has the needed components on the PCB. And at this point you need to test each part separately. You have a different code for that on electrobes.com, so you have to download them one by one and upload them to the PCB using the external FTDI module. For example, download the OLED screen test code, upload it to the PCB and see if the screen works. And if not, maybe change the I2C address in the code, and if that still doesn't solve the problem, well, you might need to check the solder connections. For the probes you will need a cable and 2 metal pins. I will get mine from a cheap multimeter that cost me only $2. I solder the metal pin on the tip of the multimeter. And then I solder the red wire with the probe on the probe pin on the other side of the PCB. So now we can measure with it, so download from below the final code. The 3D case is still in progress, and because I still have to correct some errors, I will make the final design in the next part of this project. Now remove the UART wires. Then we can solder a battery to the battery pads on the back. Slide the on and off switch and turn it on. You slide the main switch to the right and we are into voltage mode. I measure this battery using a commercial multimeter first. And then I measure it with my multimeter and we get pretty much the same value. Since the input for the voltage mode has a voltage divider with a value of 11, this multimeter could measure up to 55 volts DC. The AC voltage measurement is not ready yet, because the rectifier that I've used has a voltage drop that is too big and is not even linear. Now slide the switch to the middle position, and we can measure resistance. I measure a few resistors to check the values. And this part has a small error that I must fix. As you can see, the resistant part in the schematic is connected to some pins that I use for the other parts because the RCL negative connection is shared with multiple parts. So during each mode in the code, I put these pins as input so they won't interfere. But for some reason, the op-amp that I've used for the inductance measurement affects the resistance reading. Okay, now press the button once and we enter the capacitance mode. It can measure pretty precise capacitance from 1 microfarad up to thousands of farads. And the problem once again is for small values. Because again, we have these two capacitors always connected at the input probes, so we can measure lower values as we have did with my previous multimeter, values down to 33 picofarads for example. So my bad, I've made a mistake of using the shared pins. The solution will be to just use two external ADCs instead of just one, and that's what I will do in the next part. Okay, so push again and we can measure inductance. I measure a few values. Push again and we can also measure frequency, which is very easy, using the pulse-in function in the code and calculate the frequency. Now slide the switch to the left and enter the current mode. I've used the ACS 712 IC of maximum 5 amps. I connect a battery in series with a load and I measure the current value. And I get pretty decent values. So basically this multimeter could measure voltage, resistance, capacitance, inductance, also current, continuity, diodes, frequency, and it can also create square pulses or PWM signals. I'm also working on other modes, such as a transistor measurement. So I think this is quite awesome, right? But what do you think? The 3D case is not yet ready, but I will have it soon, and I will also fix the rest of the problems. But I think this could be a very useful product, right? Because it's small, decent precision for homemade projects, it is portable and also rechargeable, it has multiple modes and could still have some improvements. And I think that the size is the best improvement from my previous PCB, right? I hope that you liked this video, and if so, consider giving me a like or comment below. Thanks again and see you later guys. So guys, did you like this video? I hope so. Okay, so look, I would really like to thank you to all of you for the support, especially for those who are supporting me on Patreon, because that's a really nice thing to do. And if you can support me on Patreon, well, all you can do is to just like my videos or comment below in order to get more activity on YouTube. That will really help me. And if not, you have all my links below for my shop, for my website, if you want to buy my t-shirts and so on. So thanks again and see you in the next video.